This tutorial will discuss using raster tools for the purpose of interpolation. In particular, it will discuss a method known as inverse distance weighted. Interpolation is used to answer questions such as, if I know the value of points around me, what might the value be, or rather an estimate of the value of the points in between? In this instance, I have a series of points representing elevation values. So if I wanted to get a gradient of elevation, I would have to use their values in some way to interpolate my value. Inverse distance weighted, one of the most common methods and the one we're going to discuss, bases itself on the principle that the closer something is to me, the more impact it has on my value than something that is far. So if I'm trying to calculate this point right here from which the measuring is emanating, a point that is 107 feet from me will have a slightly higher impact on my value than one that is 117. Contrast that with 126, which will have slightly even less value, and 145, which will have even less. The farther you get out, the less and less these points contribute or weight the value of what we're trying to calculate in between. So inverse distance weighting is a weighted average method where the weight is the distance from the source. Double checking at first what our values are in the attribute table. In this instance, it is elevation. So we're taking a question. I have a series of elevation points, and I want to create a grid that tells me the elevation of the space between. Our toolbox, spatial analyst, interpolation. As I mentioned, a number of different methods. We're only going to focus on inverse distance weighted. Drag points in. Remember, you're limited to 13 characters. Z-value field is essentially the value upon which you want to interpolate. Elevation is a field alias. So I know that I want to use points that have elevation, and from that value, calculate the value in between. So whether you were doing this for temperature, barometric pressure, housing price, anything that follows this natural phenomena in which the closer you are to something, the more impact it has on your value, this would work. Our cell size is 20 because we've set our extents earlier. Power is where you get to choose how much weight the distance actually has on your value. A power of 2 would mean that the weight of the cell would have a intensity or a weight of 1 over the square of the distance. If I made it 3, it would be 1 over the cube of the distance, and so on, and so on, and so on. Since you're using an exponent in the denominator, this would mean that the higher you increase the power, the lower the weight you're giving the farther something gets. This tool defaults at 2. I think it's perfectly acceptable to use 2. Search radius, let's break it down like this. If you choose variable, it reads, calculate my value based on the nearest 12 points. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But do not calculate my value if you exceed this distance. This isn't quite evident from our elevation layer, which has a lot of points, but if you're imagining you're trying to interpolate with something like temperatures, where maybe you only have temperature stations that are spread out several miles from one another, you might have to look hundreds and hundreds of miles to actually try to find the next temperature station, and after a while it wouldn't necessarily have that much of an impact on your value. This would be used in that instance, but we don't need to do it now. Fixed is the exact opposite. Count up as many points as you can find within a certain distance, but expand that difference if you do not find 12 points. So this is that opposite, right? If you're searching for something really, really kind of small around you, but you can't find enough. You keep expanding the radius till you get the minimum number of points. Finally, input barrier polyline. We're going to discuss this when we do the second example of interpolation, as it has a little bit more relevance there. And here I have an interesting grid. Let me take rid of this. Perhaps I will set it to stretched. Carefully not mess with the color ramp, as that seems to crash my computer. And we have large resolution sizes, so it's difficult to see exactly. But you can imagine, you start up here in Germantown with cliffs that start to cascade down towards little inlet creeks that eventually find their way to the Wissahickon, to parts of the Schuylkill.